for a very good evening, everyone. Is it audible to all delegates?
It is audible. Voice is low, sir.
Okay, let me check. Now audible, sir?
Yes, sir. Yes, sir. Now it is
Okay.
clear.
Thank you, sir. Thank you so much. So, very good evening, everyone. And it's again my pleasure to welcome you all to this live session on descriptive statistics, first session of module 4 in our 1-month certificate program on data analysis using today in this data-driven world, tools like R empower us handle complex data sets effectively and efficiently, and that's why this is the first introductory program we are initiated, and you learn the 3 modules of this program. Now, before begin, it's my honor to introduce our esteemed resource person for the session, Dr. Puneet Kumar Gupta, sir. Sir is an accomplished scholar and a dedicated educator and a prolific researcher, currently serving as assistant professor and research coordinator at the ICFAI University, Dehradun, Uttarakhand. Sir holds a PhD in statistics from the University of Allahabad, domain in which he made significant contributions, particularly in quantitative research, technology adoption, distribution theory, and load sharing system models. Sir is a gold medalist in MPhil statistics and has completed his Masters of Science in Statistics in CCS University, Meerut. His dedication to research is evident from 40 plus research publications, 2 patents, and 1200 plus citations, and successfully supervising 3 PhD scholars while having already supervised 3 others to completion. Sir is a seasoned expert in quantitative techniques, applied statistics, and research methodology beyond academia. He is an active contributor to guest lectures, faculty development programs, and panel discussions, inspiring audience across diverse platforms. In today's session, Sir will take us on an insightful journey into the field of descriptive statistics using R software. He will cover key concepts, methodologies, and practical applications, ensuring a comprehensive understanding of how to use R effectively for summarizing and analyzing data. So, without taking too much time, now let's extend a warm welcome to our respected resource person, Dr. Puneet Kumar Gupta, sir, as he begins the module 4 with descriptive statistics and continue to the 4th session of this module. Over to you, sir. Please, sir. Welcome, sir. Muted, sir. You are muted, sir. Sir, you are muted. Please unmute at your end.
Now am I audible?
Yes, audible, sir. Welcome, sir.
Welcome and thank you, Amit, for introducing me. So before starting, I want one confirmation from the participants, whether because you have already covered 3 modules, I think. One was introduction to R, second was, I think, data visualization, and one more module you have covered. That what was the name of that third module?
Data manipulation.
Data manipulation. Okay, so whether they have covered R or they have explained the things using RStudio, because the same platform I will use.
Yes. In first and second module, the speakers use R mostly and sometimes introduce RStudio also. And in the third module, data visualization, we completely work on RStudio.
Oh, RStudio. Okay. So in this module, the first session is descriptive statistics using R. So before directly moving to the R, let me first clear the first basic concept of descriptive statistics. My screen is visible. Amit, please can you confirm?
Yes, perfectly visible, sir.
So as far as descriptive statistics is concerned, so descriptive statistics is nothing just describing the basic characteristics of the data. And if we start categorization of the descriptive statistics, so we can do categorization in 2 things. Like any analysis, we can divide into 3 parts: univariate, bivariate, and multivariate. Univariate is basically related to one variable. And that variable can be of either metric nature or the non-metric nature. Metric means the data is measured on the continuous or interval ratio and interval scale, and non-metric means its categorical data is either nominal or the ordinal. Because accordingly we apply the technique. First, we should be very clear that which type of data we have in our hand for analysis purpose. As far as the univariate analysis is concerned for the metric variable, so basically the descriptive statistics we frequently use to describe the basic characteristics is mean, median, mode, then SD, variance, CV. Even if we go for the testing of hypothesis that we will cover on the third day, one sample t-test is related to the one variable. And the nature of the data is metric. If we talk about the non-metric data and the variable is only one, so usually we deals with the two things, and that is the count, and second thing is percentage. So for the non-metric data, we usually deal with the count and percentage, and for metric data, we deal with the mean, median, mode, SD, and so on. Then for bivariate data, the concepts of DV and IV comes, and bivariate we will be moving tomorrow, where we will be covering the correlation and regression, I think, in the second lecture of module 4. So that part I will discuss tomorrow, because today we will be covering that how to do descriptive statistics of a univariate. Because if you are able to calculate mean of one variable, so if there are 1,000 variable in the data set, you can also calculate the mean of the 1,000 variables. So the thing is not the number of variables, thing is how to calculate the mean, median, mode, and the various. So that's how analysis moves into univariate, bivariate, multivariate. As far as univariate is concerned, so for metric data, we usually calculate mean, median, mode, SD, variance, CV, skewness, kurtosis. Further, we will move. And for the non-metric data, we will cover the count and percentage. So today we will be covering this part. Tomorrow we will be covering the bivariate, where we will discuss the dependent, independent, correlation, bivariate analysis. Day after tomorrow, we will be covering, I think, the ANOVA and multiple group comparisons. And one is hypothesis testing. So I think these four modules are assigned to me. So let me move to directly the univariate analysis. So as far as any basic statistics is concerned, I'm not talking about the univariate or bivariate or any statistical analysis is concerned. So basically we start with the first thing, that is measures of central tendency. In which we have usually the mean, median, and mode. Second, then we move to the measures of dispersions. In dispersions, we have lots of measures, but some of them which are frequently used are range, variance, standard deviation, coefficient of variation. However, apart from them, some of the less frequently used measures of dispersions are quartile deviation, mean deviation about mean, median, etc. Okay. Then the next stage of the analysis after the measures of dispersion is measures of skewness, where we concentrate on the type of the distribution a particular data follows. And hello.
Muted, sir. Please continue.
measures of kurtosis. So that's how any basic data analysis moves forward. Like if we talk about the data, so first either we get the data in the collected form, or we collect the data where we learn the sampling techniques. Once we have data in our hand, the first step, if you see the definition of the statistics, the collection, representation, analysis, and interpretation of any data. So basically it covers the four stages: collection, representation, analysis, and interpretation. So collection usually belongs to the sampling techniques, how you can collect the data and types of the data, primary, secondary, questionnaire, survey, sample size. These things comes into the picture. Once data is collected, then the second stage is how you can summarize the data, and summarization belongs to either the classification of the data, preparing the tables, group frequency distribution, discrete frequency distributions, and the second part of the representation of data is the visualization of the data. Okay, so that we can have a bird eye view of the data, that what is the trend, what is the pattern in the data. Once we are done with the representation of the data, the third step is the analysis. So third step, any basic analysis of the third step starts with either the percentage, count, or mean median mode, right? So because like we are learning today descriptive statistics using R, so it's not R any software you moves into. First we should be aware, or we should know that why we are using the software, because this is the modern world, and in modern world there is a word big data, right? If you are going to calculate the mean of 5 values, 2 plus 4 plus 6 plus 8 plus 10, you directly can say plus 5 divide upon 5 is equal to, that is the mean. But if you have 5,000 figures, so that will be a time taking process to manually calculate the mean. And if the things are getting complex, so the chance of errors are more. So first thing which we should know before using any of the software, it's not about R only, that we are using software for reducing our time, for making our calculations easy, so that we get the quick results and quick interpretation, and quickly we can take the action on the concern for which we are doing our research, or for which we have collected the data, or for which we are doing the data analysis. So R we are using, or any software we are using, for just ease of the calculation and reducing the time, right? Second thing, if we talk about the non-science background students, like medical students, the art students, MBA students, the other background students, they say that how to learn the formulas. Like we are not habitual to learn the formulas. Like whenever I write the formula of the variance on the board, students say, sir, how you remember these formulas? Because we are really confused. We can learn 1, 2, 5, but there are thousands of formulas. So that is another need of the for non-science background students, that they don't want to learn the formulas. Even they are not able to learn so many formulas, because they don't belong to that background. So as far as you are concerned, or the medical professionals or other are concerned, which are especially non-science background, so they have two concerns, that they are not too good with the mathematics, they are not able to learn the formulas. Like if we talk about only mean is straight away is 1 upon n summation xi. So there are number of purpose of using any software for analysis purpose, right? It's not only the reducing the calculation or reducing the time. Non-science background has also some many reasons for using any particular software. But one thing you should always remember, that if you cannot calculate 2 plus 2, usually you will not be able to understand calculate 2 plus 2 with the help of any software, right? So software will do anything. Like if you put any nominal data, rank data, and ask what is the mean, he will calculate the mean, because software is just having in data. He does not have the feelings that what type of data he is going to deal, right? So you should have the basic concepts, that why you are calculating, and how should it should be calculated manually. Then only you will be able to better calculate with the help of the softwares. So what I will do, I will start with the basic definitions, how if you are doing manually, how it will be calculated and how the same can be calculated using R. So that's how I will process. So far I'm having a pause. If you have any doubts so far, you can ask. Otherwise, I will continue. Start with the definition of the mean. Any doubt? Okay. Again, if we talk about the mean of any data, so we have usually three types of the data. Or initially, if we categorize, we have the data, group data and ungrouped data. And in group data, we also have two types of the distribution, discrete frequency distribution and the continuous frequency distributions, right? So I will start with the measures of center tendency with the raw data, or you can also call it as a ungrouped data. So quickly moving arithmetic mean, usually we denote it by X bar. For non-science background, we write the definition as sum of all observation upon number of observations. Yeah, total number of observations. If I write it mathematically, we can write 1 upon n summation xi. If we talk about the median, so median, either you can use XM naught, some books authors use only M. So it's up to them. Some authors, some of books use 𝐥 for median, right? So median is in a very raw form is nothing, just the middle value of the order data set. And if I write mathematically, so mathematically median is n plus 1 by 2th observation. N is the total number of observation. If your total number of observations are odd, and if it is even, then the formula for median is n by 2th observation plus n by 2 plus 1th observation by 2 if n is even. Because the thing is that software will give you any value. You have to relate that whatever software has calculated, whether it is related or whether it is correct or not. At least you should have a basic idea that whether whatever answer software is giving, whether it is correct or not, right? And mode, if I say mode is nothing, just the most frequently used, most frequent values of the data set. The value which has have occurred most frequently in the data set is usually the mode. So most frequent value of the data set. So let me move to the R, that how we can do the same in R. It's your choice whether you want R or R Studio. I have opened both. Anyone I can use. If you are comfortable with anyone, you can let me know. Otherwise, I will use R Studio. Okay, so let me enter a univariate data. Let me, we suppose we have the heights. Suppose there is a vector in which we have number of values. And let me define the values 160, 172,
Sir, you are muted.
Okay, I don't know how I got muted, but now I'm audible.
Yes, yes, sir.
Okay, so suppose some of the values in the data set are given and you have to calculate the mean median mode of the data set. So there are two ways. One, like you do on your copy, like whatever, if you are doing it manually, so what you will be doing, you will be summing all the observations and then dividing by the number of observations. So mean X or mean height I'm typing. So mean height can be calculated as sum of height upon number of values. For number of values, the command is length. Length will tell you the number of values in the height variable. Okay, so that's how manually mean will be calculated. Let me run it, and that's how the mean of the height, average height is calculated 164.2. So that's how you will be doing on the manually on your pen or paper. However, R also has a direct function for some statistical measures like mean, median, mode, variance, SD. R also has direct command. So direct command is mean. So if you write mean bracket open bracket close and the variable name, you will be able to directly calculate. Okay, I'm running the second command. So that second answer is the direct calculation of the mean and the first answer is the manual calculation of the mean, right? And both the answers are same. Now, since you know the vectors or you have learned one lecture on the introduction or the data manipulation in R. So how you can calculate the mean of the first 5 values? Can anybody tell me how we can calculate mean of first 5 values? Okay, so if you do the square bracket with the variable name where the variable is the vector. So you write 1 into colon 5. So that means that that command will give you the average of first 5 values. Let me run the command now. The answer is 167.4. Have you heard the word trimmed mean? Basically, there is a concept of in data cleaning. One characteristics of the data cleaning and one problem of the data cleaning is the outlier, right? And if we have any doubt that our data may contain the outlier, then we basically prefer trimmed mean in place of the mean. So what trimmed mean does, like if we are calculating 5% trimmed mean, that means we are avoiding the 5% upper values of the data set. Upper value means first 2.5% and the last 2.5% values will be avoided, and we will be calculating the average of the middle 95% values. So what will happen, because outlier either will be the lower outlier or the upper outlier, so they will be removed from the data set and your mean will be the more consistent mean. So how you can calculate the trimmed mean in R? So the command is same, only you have to type the additional argument. You have to pass the additional argument, and that additional argument is trim is equal to true. Okay, so true means you are passing the trim is equal to true. Trim is equal to percentage you have to give. Whether you want 5% trim mean, 1% trim mean, it's up to you. So if you want 1% trim mean, you have to type 0.1. If you want 5% trim mean, you have to type 0.5. So that's how you can calculate the trim mean. So now I have calculated the 1% trim mean and it is 164.375. Right? Sometimes what happens that we have missing value in the data set, especially when it is a survey data and some of the respondent did not answer to a particular question, the value becomes the missing value, right? Now I'm creating one missing value in the data set. NA I have typed, that means that value is missing or not available in the data set, right? Now, if you are going to directly calculate the mean of data set, the answer will be NA, because there is one missing value in the data set, and that's why I will not be able. Okay, I have not run the hide command. Answer is NA. Why it is NA? Because one of the value is NA. That's why is not able to do the sum and not able to get the mean height of the data set. Okay, so how to deal with the data set or how to obtain the mean median mode? Even it will work for the other command also. Like for median, if I tell you the trim is equal to 0.1, it will also work on the median also, right? So that is the beauty of the R software, that whatever argument we have, it mostly work. Like data visualization, if you are doing, so if you want to add color on a particular graph, so the command is safe for all type of the color graphs, like COL is equal to, and within quotes you have to type the color name. So that command is fixed for all the graphs in the R. So that is one advantage of using the R, that the once you know the argument what is to be passed for a particular work, that argument will be same in more or less same in all type of the commands. So what you have to do, na.rm is the command, and where na.rm is true, that means there is a na value or the missing value in the data set. So if you pass true, that means it will consider, or I will think that yes, there is a missing value, and now he will calculate the mean accordingly. So that is the 164.55. And what was the earlier height? The original data was having 164.2, and now, and that creating one missing value in the data set, the mean is 164.55. So if you have any feeling, you do not need to look at the data that let me scroll the all the rows and whether there is a missing value in the data set. No need to do that. You, if there are or if there are not even missing values, you type na.rm, always you will be getting the answer. Doesn't matter whether it has the missing value or not, right? So I'm not moving to the geometric mean or harmonic mean, because if we start doing the measures of center tendency, so there are two type of average: positional average and the mathematical average. Mathematical average, we have mean, arithmetic mean, geometric mean, harmonic mean. And if we talk about the positional average, we have median and mode. So usually we have total 5. Usually people call mean, median, mode, but we also have two more type of average: geometric mean and harmonic mean. However, by writing the commands you can calculate, but since they are not too frequently used in the descriptive statistics or the statistical analysis, so that's why I'm not going to explain. However, if you want, I can also explain the geometric mean or the harmonic mean. Now moving to the median, second measure, that how we will be calculating median of the mean of the raw data. I will also send these R code to Mr. Amit. He will be sharing with the students so that you can do practice today, and even if you have a doubt, you can ask in the starting of the tomorrow session, right? So median is nothing, just the middle value of the order data set, right? So see, suppose 2, 4, 5, 6, 7, 9. This is the data set. So directly, because since these are the ordered values, middle value is this, and that is the median. If you add one more value, now the median will be the average of middle two values. So that's how in a very raw form we just have an idea that what will be the value of the median. Now, if we move to mathematically how we calculate median, so median depends on two values. First, you have to do the data set in order, either increasing or decreasing. So what we will be doing first, we will make the data in order. So for order, the command is sort. So that will put the data in the increasing order. Second, first we will be seeing the length of the data set, and then we will be seeing that whether it is even or odd, right? For even, the concept is, the formula for median is n+1 by 2th observation of order data set for odd. And for even, it is basically the average of the middle two values for even. So in R, if I calculate manually a if loop or if conditional statement, I have to pass. Okay. So how I will move in forward into R? First, I will enter a height or a data. I will calculate the sort. That will sort the values. I will calculate the n. N will be calculated as length of x, or then I have to type the if statement. If n modulo 2 is equal to 0. That means the meaning of this command is whether the n is divisible by 2, because we have to check whether n is even or odd. And the concept of even odd, we check if the remainder is 0, the data is even, the value is even. And if it is no remainder is not 0, that means it is odd. So that's how we will be writing it as n modulo 2 is equal to 0. If it is, that means it is even. Then you start curly bracket and then you can directly type print. Let me move to R only. You will get better idea. So I'm taking height only, right? For this data only, will be calculating the median. So S height I'm typing. S height means sorted height, right? I'm doing sort of the height variable. And if you want to print it, you can type semicolon S height. So the same command will be run and it will give you the answer also. Now you can see in the output that the all the data given is now sorted, right? Now n I have to calculate. N is the I have to close my there is some issue with the R Studio. Hmm. Hmm. What's the file? Hmm. 𝐿ENGTH. And if you want to print n, what is the length? So n is 10. So these are 10 observations, and in has height, we have sorted them, right? Now you have to run the if command. If is in a conditional statement, which will be checking the condition. The condition is if n is even, that is the formula, and if n is odd, that is the formula. So if capital N modulo 2 is equal to 0. Right? If you directly type this command in the command prompt, it will give you true, false. True, that means our data is even. So if n modulo 2 is equal to 0, cat is command for printing. Either you can use the print command also, but it will not take the other variable in the output. So what will be the median? If it is yes, so it will be n by 2th value plus n by 2 plus 1th value and their average. So you add them, both of them, and divide by 2. That I have used the formula for the even because we are in the S. Yes loop. Else means otherwise. So otherwise, again, I'm writing the same command, but here you have to type the formula for odd. And formula for odd is I think one more bracket will come here. Okay, so that is the concept if you manually calculate the median in R. And what is the concept? We have the data height. What we have done, we have sorted them. What we have done, we have calculated the value of n. Then we check whether n is divisible by 2. And if it is divisible by 2, that means the remainder is 0. And if it is, then median is equal to height n by 2 plus height n by 2 plus 1 and their average. It is nothing, just the n by 2th value of the data set, n by 2 plus 1th value of the data set and their average divided by 2. Otherwise, else median will be the n by 2th value of the data set. Why there are two? It is, I think, n plus 1 by 2th value. Okay, let me run the command. Somewhere bracket mistake is there. One bracket here is missing. Median is how much? 222.5. Right? So that's how median will be calculated in R for the raw data. Now, if we talk about the direct command, so directly you can type median, the variable name, like mean, bracket open, bracket close, the variable name. Similarly, we can type median. Okay, somewhere there is a mistake in the calculations. I don't know. Some bracket mistake is there, otherwise that's how median will be calculated. Okay, S height I have to type because S is the sorted height. I was directly typing the height only. Okay, now we got the same answer, 164 manually and 164 using the direct R command, right? Now, let me write the direct. that comment I'm making so that you can easily understand that what I'm going to cover in this part or for what purpose I have used the particular command. So that part is for median, right? And that part is for mean. And if I talk about the now let me move to the mode. Okay, however, I don't know the reasons, but there is not much options available for calculating mode in R. If you see the most of the softwares like if you see the SPSS, you see the Excels, there are direct command for calculating the mode in these softwares, but R don't have any R command for calculating mode, right? So one is that first you have to prepare the table command. If I type the table height, so it will give you a discrete frequency distribution. And even here you can see that only values are repeated only the once, only 172 is repeated by 2 times. So I think the answer should be 172. Mode should be 172 of the data set. Okay. Any doubts so far you are having?
Hello.
Ajay, Mr.
Sir.
Ajay, if you have any doubt, you can ask.
Hello, sir.
Yes, yes.
Sir, when you explain that mean types, then mean and arithmetic mean both are same or what, sir? The general mean what we study or arithmetic mean both are same or they are different?
Like, sir, when we start teaching or in the initial session, when we start the measures of center tendency, like after the representation of the data, we start analysis. Analysis start with measures of center tendency. Measures of center tendency starts with the two type of average, or even one of the another name of measures of center tendency is the average, a measure of average you can say. Like we want one value that can represent the entire data set. That is the only concept behind measures of center tendency. Central value, average value, mean value, basically they are more or less similar thing. So we start categorization of the average. There are two type of average: mathematical average, positional average. Mathematical averages are arithmetic mean, geometric mean, harmonic mean, right? But geometric and harmonic mean in research we don't use frequently. They are more related to the engineering background field, right? So that's why we omit the arithmetic word and we simply say mean, median, mode. So mean is nothing. This whatever mean you are studying or you study through your entire research is arithmetic mean.
Yes. Yes, sir.
Any other doubts, sir?
No, sir. Clear.
Okay. So mode we will be calculating. For mode, let me see the command because there is no direct command of calculating the mode. One more thing I was saying that even if you want to calculate trimmed median, so that command here also will work. So that 164 is the 1% trimmed mean, right? For calculating the mode, you have to type which that is the command for calculating mode. The concept is key. What is the maximum value in the data set? If you see that that 2 is the most repeated value and this 2 belongs to which position, that belongs to 172. So that's how you will be able to calculate the mode in the data set. Okay, X is not there, height is there. So that command will give you two values, 172 and 7. So 172 is the mode and 7 means it is the 7th position value, right? So your mode exists at the 7th position value with the value is 172. So that is the only way. However, some other packages through you can directly calculate the mode, but as such, like you have the command, direct command for mean and median, there is no as such direct command for calculating mode, especially in our software. So that is the manual calculation of a mode in R. And I can make the remark here that there is no direct command. So that is mode for raw data. Any doubt if you have? Now, if we talk about the group data, so for group data, again, you have to do manual calculations or weighted mean. Mean can be calculating using the weights command. But see, like there are two things people usually say that why the things are not there, like to prepare the frequency distribution. So let me go into the background. Why we prepare frequency distribution? Why we summarize the data? Okay. Why group data? So basically, group data concept was there when there was no as such softwares. So the basic purpose of doing grouping of the data, making discrete frequency distribution or the continuous frequency distribution was that you can condense the data. Like measure of center tendency, you want only one value of the entire data set. But between the raw data and measures of center tendency, there was one representation of the data. Representation of the data either through graph you can have a basic idea of the data, or through table you can have the basic idea. So the purpose of grouping the data was, or making the discrete or the continuous frequency distributions, that you can little condense the data. You are not condensing it to a single value only, you are condensing it to some of the values through which you can have the clear bird eye view of the data set. So that was the purpose, and accordingly there were formula for calculating the mean, median, mode. Mean for discrete frequency distribution, mean for continuous frequency distribution. So I will not be calculating the mean, median, mode for discrete and continuous frequency distribution, just giving you an idea that how it will be calculated if you are going to calculate it, right? So like discrete frequency distributions, you will be having the data in this form. You have values on X, and then accordingly you have frequencies. So formula for mean will be 1 upon n summation fi xi, yeah, xi fi, doesn't matter. So basically manually, if we say what we do prepare a new column x into f 0 5, we multiply individual x by individual f 14 12 and 12, and then you sum it 43, and sum of frequency is 7 14 21. So the answer is that n is basically the sum of f. So mean will be 43 upon 21 and it is approximately 2.1. So that's how you calculate the arithmetic mean for the discrete group data or the group data. If we talk about the in R, so in R you will be having a data X, you will be having a data F. So nothing you have to do, you can do just one thing here. That I'm again moving to the same command where I have calculated manually. So cease. Here, what you have to do, let me type the frequency. Let me type this complete. Group data in bracket, I'm writing discrete because grouped is again of two type, continuous and discrete. Right? So suppose you have, I'm writing not height, simply writing X. So suppose you have some data in the X variable and respectively you have the frequencies. So the mean will be calculated like that. Sum fi xi. That means value into frequency. So you can straight away type x into f. That is basically summation fx. And upon either you can type sum of f. So that's how you can calculate the mean for group data. Okay, xi. Okay, so that's how you can calculate the mean. Similarly, in median, like what you have to do, again check even odd, then find the median class, then calculate the cumulative frequency. So there is a long procedure for calculating the median for the group data, right? And even if it is continuous data, then lower limit, upper limit, frequency, cumulative frequency. So there is a long process. However, if you see the like median, we frequently use in the non-parametric test. In all the parametric tests, we frequently use the mean. So mean is one of the most widely used measure in the entire statistics or entire data analysis process. That's why we focus more on the arithmetic mean. However, I will suggest you try calculating the median for the group data by yourself. You try today. If you are not able to do it, I will explain you tomorrow. But if you will be having a try and if you will be having a doubt, then only I will be explaining median for the group data. Otherwise, we don't frequently, like we don't have the group data as an analyst, as a statistician, as a researcher. Either we are using the secondary data or primary data. If we talk about the primary data, the data in the raw form. So most of the times we always deal with the raw data. And since we are using the softwares, we don't try to summarize the data. We don't try to create the frequency distributions, right? If you read the research papers, in research papers, you will not see any of the papers. I'm not saying any of the papers, but 99% research papers, the first table is the demographic characteristics, count percentage. The second table is either they have used the correlation, regression, prediction, or they have used testing of the hypothesis. No paper you will see that they have prepared a discrete frequency distribution, continuous frequency distributions, right? Because they were the classical techniques. Like we have calculators only. We don't have access to softwares. So that was one way of reducing the data. Like we don't have the software, so manually we can little condense the data. So that was the basic purpose of preparing the mm, frequency distribution or making the data group. Otherwise, in the real world or in the, doesn't matter, it is a big data, we straight away put the data in the software and directly. Doesn't matter we have thousand, millions, billions of the values, R will take 1 second to calculate the mean of the entire data set. Right? So if you are interested, you can go to the calculating the median by yourself for the group data. Right? Now let me move to the measures of center tendency. Sorry, measures of dispersions. So we are done with the mean median mode. And now I'm moving to the measures of dispersion. Okay. Let me have 1 minute that why we move to the dispersion and what is the meaning of or basically the objective of moving towards dispersion. So what happens, suppose you have two things, x and y, you compare them on the basis of measures of centered tendency. For examples, you compare them on the basis of the average. So in real life, what happens, sometimes the average of two things are more or less similar. So in case when both are more or less similar, what you will do? You are not able to compare both the data set, like performance, score, whatever is the characteristics behind the mean. But since you are going to, the objective is to compare two things. You are comparing the first basic statistics, you know, is the mean, median, mode. You calculate the mean for the both the data set, and the mean is by chance the same or more or less same, right? So what you will do then, in this case, measures of central tendency fails to compare the variables, fails to compare the data, right? For example, I'm giving you a cricket match, like there is a series, and in that series there are two players, Dravid and Sehwag. And in the 3-match series, Dravid scored 110, 100 and 90. And Sehwag calculate, scores 200, 100, 0. So if you don't look at the values, you see them, treat them as a data set, and you say that ki average scores iska zyada raha hoga, that will be a better player, and that player should be the man of the series, right? But if you see the average score run by both the player is 100 in this case, that means statistics is suggesting that both players are same, right? You are not able to compare the data set. And if you individually look at the score, straight away you will say that Dravid is more consistent, more reliable, because has scored approximately 100 in each match, right? Sehwag ka hai chala chala nahi chala nahi chala, right? So that consistent word automatically comes. I will not tell you measure of dispersion, but straight away you say that Dravid should be the man of the series because he has consistently performed in all these matches, right? So the basic concept behind this, that measures of center tendency here fails to compare two things, right? That's why we are moving to the next measure, that is measures of dispersion. Where things are, averages are same, then we are looking for the dispersion. Dispersion is basically the meaning is फैलाव, scatterness, how much they are dispersed from their central value, that is measure of dispersion, right? So that is the basic idea, that why we move, why mean, median, mode are not sufficient to compare any of the data set. That is the reasons that in real life, so data exist, variable exist, characteristics exist which have similar averages, and here we fails to compare the data on the basis of mean, median, mode. That's why once we are done with the mean, median, mode, we calculate measures of central dispersion. So measures of dispersions, if I talk about, uh, the first and very basic is the range. Range is just nothing, just the minimum and maximum values. And if you have to calculate the range, like range sometimes is written in the interval, like 10, 20, you will say is the range, where 10 is minimum and 20 is maximum, and length of the range can be calculated as maximum minus minimum value. So that is the one of the very basic measure of the dispersions. Then we move to the variance and SD. All of you as a researcher might be aware with both the words because they are most frequently used. Mean, variance, SD. These three words are very widely used regardless of the background, the area in which you are no research, even on if you are doing research on Kabir Das, that thesis might also have used somewhere mean or SD. Next, coefficient of variation, CV, covariance, COV. Then we have quartiles, deviation, QD, right? Mean deviation about mean, median, and lots of measures of deviations are there. But the most popular are range, variance, SD, and CV. And in correlation, we also use the covariance term, right? So manually, I will be calculating only one. That range I have already tell you. You do maximum of x minus minimum of x. That's how manually range is calculated. And direct command for range is you type range x. So let me finish first range quickly. That how we can calculate the range. So now putting the heading measures of this person. Time हो गया अमित शायद ना?
No
I will
problem,
take
sir.
10 minutes. I will take 10 minutes.
Problem, sir, no problem.
Okay, so measures of dispersion. First, I'm typing range. So range, keeping the same variable x, because typing x is easy for me rather than typing the variable name, height, etc., etc. So keeping x only in the memory of R. So range. So I direct command is you type range x, and manual, how you will calculate? But minimum and maximum, either you use the cat function or either you type manually, like, right? So range 12 and 19. So minimum x 12, maximum x 19. So that's how range is calculated. Let me tell you the manual calculation of mean SD because they are important. So because SD is nothing, just the square root of the variance. So if you are done with the variance, so just take the square root, you will get the SD. So variance is for raw data 1 upon n summation xi minus x bar ka whole square. That is the formula for variance, and SD is just, it is usually denoted by sigma square. It is sigma. It is nothing, just the square root of the sigma, a square root of the expression, whatever written. If I talk about the R, so in R, first you will be having the data set. You calculate the length, number of values in the data set, length x, then mean x, because in the formula of variance you can see that mean is also there, xi minus x bar. So mean x also I'm calculating in advance, and mean I'm calculating using direct command, right? Now variance x you can calculate, first it is the sum of something upon n, and sum of something is sum of this within bracket what you have, something square, and that something is x minus mean x. Okay, so that's how manually it will be done in R. So let me quickly type x we already have. Let me calculate the however mean x I directly can write in the formula, but it is better to store the mean value in a value that, and every time I can use the word mean x, right? So where x I can calculate as sum of something upon n, where n is the length of n. In something you have square of something, and that square bracket nahi laga na, and that square is x minus mean x. So that is the basically the formula, and if you want to print it, just type where x. So let me run the command. Somewhere bracket mistake I have done. X यू इतना छोटा है ना, दोबारा लिख लूंगा उससे बढ़िया। I have not run the n command in the memory of R, that's why it was not given. So variance of x is 6.64. And similarly, if you want to calculate standard deviation, it will be just put the square root, and for square root the command is sqrt, right? So that is basically the SD, right? And if we talk about the direct command, so you have to just type where x will give you the variance of x and SD will give you the standard deviation of x. But the answer may not match because the R use the formula 1 upon n minus 1. And the basically for the popular, because there are two formulas, two concepts. One, we start studying the basic statistics where we study the formula 1 upon n, and when we move into the inference, statistical inference, point estimation, testing of hypothesis, then we have two words: population mean, sample mean, population variance, sample variance. So in population variance, the formula is 1 upon n. In sample variance, the formula is 1 upon n minus 1. So in inbuilt command of R, the formula is n 1 upon n minus 1. So variance x is 8.3, while our variance, manual variance, was 6.64. That's why this is the difference, because R use the comma formula 1 upon n minus 1. So if you keep here n minus 1, you will get the same answer, right? CV, you can coefficient of variation, you can directly calculate as var x, sorry, SD है ना, STX into 100 sigma into 100 upon x bar. So that's how manually you can calculate the CV. Okay. Now come to the skewness and kurtosis. Kurtosis. So again, they are generalized formula, like is for moments we have the formula mu r is equal to 1 upon n summation x I minus x bar ki power r, right? So again, if you are able to calculate the variance, you will be able to calculate the moment, and skewness is based on the moments. So why we are using the software to ease the calculations? So I will be using the direct command. So there is a package moments. Okay, so you install the package moments and you will be directly able to calculate the skewness and kurtosis, right? Let me check whether I have the package or not. Yes, I have. So you can write moment is the package through which you can directly calculate the skewness and kurtosis. So skewness x, kurtosis x. Okay, so through this package you can directly calculate the skewness and kurtosis, right? So that is the complete basic or descriptive statistics from my side, where I have covered the mean, median, mode, standard deviation, SD, CV, range. Even covariance you can also calculate using the, for covariance basically comes in the bivariate, so it will be discussed tomorrow when we will be studying the correlation coefficient, especially the Carl-Pearson correlation coefficient, because covariance is between two variables, right? So it is bivariate. Today we have discussed the univariate analysis and the descriptive statistics. If you have any doubt, you can ask. I will send these R code to Amit sir. He will be forwarding it to you so that you can do practice. Come tomorrow with any doubts if you have. Otherwise, we will continue with the, I think correlation is tomorrow, correlation and regression. Mr. Amit, Amit sir, it's over to you if anybody has any doubt.
Yes, thank you, sir. Thank you so much. So is there any doubt? Delegates are free to ask. Otherwise, you can ask tomorrow also. Practice these steps. I will share the codes and just try all course by yourself on your own data sets.
Actually, 1 hour is very less for teaching. Like these are lab sessions and these take times. Right, practically, if there are 30 students in the lab, 3 hours it takes the same things, right? And everything, even R, we forget the command. Like I was forgetting the command for mode because I never use mode. I have written 40 plus research paper. Even in a single paper, I don't have used the mode. So we also don't remember the command. We only remember those commands which are in daily use, right?
Yes, definitely, sir. And as we know, all delegates come from medical background mostly, so then rarely used.
Median you will be using in non-parametric. In medical, we usually have the metric, non-metric data. So median is frequently used. So median you can calculate, but there is no meaning in the group data, right?
So if there is any doubt, we are open just 1 minute more.
Ajay Kumar, because you were having your camera on, you were listening. Even I am only able to observe you, right? So if you have any doubt, you can ask. Even others also can ask, right? And even you can give the feedback if you want any improvement or any other way for the tomorrow sessions. I can implement the same.
I have learned some points today actually from this mathematical type. Generally, we it means that damage so like that. So the formulas I have understood formulas actually very easy formulas. And I have just want to answer the group and ungroup. You have can group.
Can you, because I'm not able to listen you, your voice is very low.
Hello, now audible, sir.
Yes.
Yeah.
Just confusion in grouped and ungrouped, sir. I have heard this one is first time actually grouped.
Okay, I will prepare a separate slide tomorrow where I will explain both the things, and in the tomorrow starting session, I will start with this topic only, right?
Okay, sir. Thank you, sir.
Thank you, Dr. Ajay, for discussing. So thank you all delegates. Thank you so much, sir, for
Thank you.
making all
Thank you,
concepts
sir.
very easy.
Thank you, Amit sir, and we'll meet tomorrow.
Yeah, so we continue tomorrow session. Thank you all the delegates. And if anyone missed the starting of the session, we will share the recording usually. You can go through it and revise the session.
I also will say the R code, whatever I have typed today. Thank you, Mr. Amit. I'm leaving now. Can I leave?
Yeah, thank you, sir. This is the end of today's session.
Okay,
Tomorrow
thank
we
you.
continue at 7:30.